Hello, so here we are talking about potential and kinetic energy. So the first thing we're going to talk about is what is energy? So energy is the ability to cause change. Everything except for feelings and ideas make up energy or matter. Energy doesn't have a mass or take up space. So with that, looking below, which of those things are examples of energy? I don't know. What do you think? We've got air, light, love, atoms, or heat. So this says everything except feelings and ideas is made up of energy or matter. So air, we've already talked about that, is made up of matter because it's got different atoms and things that it's made of. Light is energy, that's radiant energy. Atoms are matter. Heat is thermal energy because we can feel things moving around, the heat on our hands. The one that's not energy or matter is love because that is a feeling. So the two types of energy we're going to be talking about this week are potential energy and kinetic energy. So potential energy is energy that's stored in matter waiting to be released. Some really good examples of this are a bow being pulled back. So not when it's just sitting there, but when you pull the bow back, it's got all the potential of sending that arrow shooting out there. So that is a very good example of potential energy. If you look at this man holding that rock at the top of the hill, there's a long way down to the bottom of the hill. There's a bunch of potential energy just waiting to be released there from the top of the hill with that big old rock. The food that we eat, if an apple was sitting on my counter right here, that apple is just potential energy waiting for me to eat it so my body can turn it into energy that I can use to move around. Gasoline or diesel fuel, either one, is another great example of potential energy. So that energy that's in that gasoline is waiting to be released in the motors of our cars or trucks or even lawnmowers or whatever else that we could put gasoline in and make an engine move so that we could do mechanical energy or turn into kinetic energy. So do you see any similarities about all of these examples? All of these are just energy waiting to be released. Next, let's talk about the kinetic energy. So kinetic energy is the energy of motion that's released from stored energy. So there's an arrow being released from the bow. It's in motion. It's flying through the air. An object rolling down a hill. So you remember the potential energy, we had a guy that was holding that big old rock up at the top of the hill. Well, here we have a bicycle rolling down the hill. So that bike is not potential anymore because it's moving. So our muscles moving, these people are running. That's a good example of kinetic energy. They're in motion. And then a car moving. So the car has gasoline in it. That potential energy in the gasoline has turned into motion. It's turned into kinetic energy. So the question here says, what similarities do you notice about all of these examples? So I see all of these are examples are things that are in motion. So the arrow's moving, the bicycle's rolling down the hill, the people are running, and the car is moving down the road. Kinetic energy is the energy of motion. Here we've got potential and kinetic energy. We're just going to talk about them for a minute. So energy can change from potential energy into kinetic energy. So the way we could see this is like with a yo-yo. Have you ever played with a yo-yo before? When the yo-yo's up here at the top of your hand, that is a bunch of potential energy because it's got a long ways that it could fall down, right? Once it starts moving, that potential energy turns into kinetic energy as it goes down. The faster something moves, the higher the kinetic energy. The higher up it goes, the higher the potential energy. So if we look at the biker here on the hill, he's got kinetic energy when he's going up the hill, but the potential energy is climbing the closer he gets to the top. When he's at the top, he's got the highest amount of potential energy because he's as far up as he can go. When he starts moving back down, that potential is turning into kinetic energy. The closer he gets to the bottom, the higher the kinetic energy gets. So the faster he's moving, the higher that kinetic energy gets. So here's a roller coaster, goes from potential energy to kinetic energy as it rolls down a hill. We're going to have a few more things to look at roller coasters that'll kind of explain this a little bit better, but same idea as a bike rider. He's potential energy in a roller coaster at the very top of the hill. As you go down the hill, your potential energy is turning into kinetic energy, and the faster you're going, the more kinetic energy you have. Height is not the only way for potential energy to change to kinetic energy. Can you think of any other ways that that might happen? Molecules stored in energy in their bonds. So chemical energy is stored in the bonds of molecules. These molecules can be broken down to release that energy. So this has actually happened to all of us right now. The food that we've eaten is going through a chemical change in our bodies, and it's turning into kinetic energy, making me able to talk to you. It's making me able to move my hands around. You guys are able to get up and run around because of the food that you eat. So when you eat, your digestive system breaks down food into molecules, and they're sent to every cell in your body where they're broken down to release the energy we need to live. Another example is gasoline. You can kind of think of it as food for your car. When you burn gasoline in a car, the molecules break down and release the energy and burning, giving the car what it needs to move. Kind of cool, right? So we've got a roller coaster thing that is in a link below that you guys can go play with. We're going to have a little video about that because I want to talk to you while you do it. While you do this, answer the following question. So why don't the roller coasters make it all the way through the first time? And then what could you change to make it work? So hang tight on that. We're going to go check that out in just a minute. The energy in food. Food can be measured by the amount of energy it has. For example, a piece of buttered toast has about 315,000 joules of energy. A joule is just like a unit of energy. So with that amount of energy in a piece of toast, you could jog for 6 minutes. You could ride a bike for 10 minutes. You could walk briskly for 15 minutes of the energy from a piece of toast. You could sleep for an hour and a half. You could run a car for 7 seconds at 50 miles an hour. A light bulb at 60 watts for 1.5 hours from the amount of energy in a piece of toast. Or you could lift a sack of sugar from the floor to the counter 21,000 times from the energy that is in a piece of buttered toast. Kind of crazy, right? So the energy we eat, we could turn into all these different things. I mean, it might be a little bit difficult. That's just a good comparison. So the calories in the items below, 5 pounds of spaghetti could brew a pot of coffee. I mean, there's enough energy in that spaghetti. You could brew a pot of coffee. 1 piece of cherry cheesecake, I love cherry cheesecake, by the way, could light a light bulb, a 60-watt light bulb, for an hour and a half. 217 Big Macs could drive a car for 88 miles. If we could get that energy from the food turned into the energy that these things need to run, that's what we could do with them. That is just kind of crazy. Let's see. We're going to build a roller coaster, but not today. All right. So, y'all are amazing. That is our little PowerPoint on potential and kinetic energy. Go ahead and go below because we've got some more cool things for you to do today, okay?